So yesterday when we were talking about law of sine, we're talking about how if you have two angles and two sides, then you can make use of law of sines to find out the missing item. It could be a missing side or a missing angle. Just make sure that you know. Now, if I would ask you, can you write down the law of sine at the top of the page? Can you? Okay, try it. Can you write down the law of sines at the top of the page without looking at your notes? Can you write down the law of sines on the top of the page? I can give you a start. A over. Okay. A over. Okay. A over sine A, B over sine B, and C over sine C. Okay. You can use any two fractions. Okay. Again, all it's required, it's you have two sides and two angles, and they are opposite to each other. Okay, two sides and two angles, and they are opposite to each other. Now, what about law of cosines? Well, law of cosines, it's used when you have three sides and one angle. Okay, three sides and one angle. And if you are missing any one of these items, then you can use the law of cosines to find it out. So you have, so now it may look scary when you see 6 equations right here, but they're actually the same one. We're just helping you to rearrange it. So I would suggest that you look at this as your main one, and then you look at how the other one comes into being. Now, the really, really important thing is that first, it resembles somewhat to the Pythagorean theorem, somewhat, except that there's a little appendix at the end of it. Now, the key thing right here is to look at these two. These two would be the key things to look at. Right? If on the left-hand side you have a squared, then at the end you do cosine of a. All right, and then if you have b squared plus c squared, then you do 2bc. So that's how you would apply the law of cosines for this particular purpose. The law of cosines for this particular purpose. A squared plus a squared is equal to b squared plus c squared minus 2bc cosine a. Now it can be used for any triangle. Okay, it's not for right angle triangle. It's not for right triangle only. It's used for any sort of triangle. Okay. So what you see for the second and third version, that is just for the other two versions here, they're just rearranging the variables. But what you can see here is that if it's a b squared on the left, then it becomes cosine b. So what you can see here, it's for the last item here, all the 3 letters are different. Okay, all the 3 letters are different. The 2 letters following the 2 letters following the number 2 will be the ones that we're adding together. Okay, AC, AB. So that's sort of like the pattern that you will see here. And if you would like to solve for cosine A, well, then you just throw the b squared and c squared to the other side and divide it by negative 2bc. So you have these versions. So for me, if I were you, well, I hope you know that I'm not a big fan of memorizing some useless stuff. I would just memorize the first one. Plug it in and solve. Okay, you're PreCal students. You should be able to handle all these things, okay, very well. So again, I just need to make sure that the A right here and the side A on the left, then we're doing cosine A. So the side and the opposite angle, they are the major character here. So, by the way, if you need a calculator, go ahead, take a moment, come get a calculator. You will need them. All right, so let's go ahead, take a look at these examples and see how we are finding out the missing parts. So we have a triangle ABC, and we have a angle C right here that is an obtuse. Okay, so let's just say this is C, this is A, this is B, this is 100.5 degrees. Ooh, let me write this better. 100.5 degrees, A is equal to 1.2, B is equal to 2.6, and we have to solve this triangle. Okay, now I would say that make sure that you have some tools ready for you. You have this law of cosines, and you also have the tools from yesterday, which is the law of sines. Okay, now in this case, let's go ahead and find out what angle, what length C is while we are here. Okay, so we have three sides, 1, 2, 3, and one angle here. So it makes it a perfect scenario, perfect situation for us to use our law of cosines. So we'll say C squared, it's equal to the other two sides square, A squared plus B squared, minus 2 AB cosine of C. Okay, again, let us see here, side C and an angle C. They should be one in the front, one at the end. And now you would go ahead and substitute all the essential values. So you have 1.2 square plus 2.6 square minus 2 times 1.2 times 2.6, and then cosine of, cosine of 100.5 degrees. All right, now remember that this is C squared, so your notation would help you very well. And what you do, just type everything into the calculator. 1.2 square plus 2.6 square minus 2 times 1.2 times 2.6 times cosine of 100.5. And make sure you are looking at your screen while you're typing to make sure that you don't have any typo. So you should have something like 9.337 for C squared, and C would be 3.056. Can you all get the same number? Okay, make sure your angle, make sure it is in the, make sure that it is in the degree mode. Okay. So now we have side C. Any question on using the law of cosine, sorry, law of cosines? Okay. So if you have it, then we say, all right, we got a side, and let's go ahead and find out the angle. Let's say angle A. What's angle A in this case? Now, at this point, you have your options. Would you like to use law of cosines or law of sines to find out angle A? Which one would you prefer? Law of sines? I think so too. So so for law of sines, I would say, now I would choose this one, and sine A over 1.2 of sine A over A, it's equal to sine C over C. So in this case, we have to use our newly calculated value because there's no other way to calculate it. Okay, so we have sine of A over 1.2, and then sine C, it's sine of 100.5 degrees over 3.056. So to get sine A, you have sine of 100.5 degrees over 3.056 times 1.2. So now you can go ahead and calculate this. Sine of 100.5 times 1.2 divided by 3.056, which gives you a 0.386. Now, this is where your notation is very important. This 0.386, it's sine A. It's not A yet. To get A by itself, you have to do the inverse. So you find out the inverse of 0.386, and that would be 22.71 degrees. Okay, 22.71 degrees. Okay. So I think this is a lot easier to handle using the law of sines rather than using the law of cosines. So it's just something you can choose. All right, now, how should we find out angle B? Would you use the same thing? Or is there an easier way? Yeah, 180, right? 180. So so for angle B, you just need to find out some measure of angle B is just 180 minus 100.5 degrees minus 22.71 degrees, and you have your angle. All right, so that should give you a 56.79 degrees. So I think, well, I would like to use the word fun, the fun part. I'm not sure if you would kill me for this, but the fun part here is that you have to know your tools. The tools are law of sines, law of cosines, and as simple as adding all the angles together to give you 180 degrees within a triangle. Something that it's like pretty ancient. Okay, back in geometry time. All right, so I will let you go ahead and try the bottom example. So for this one, you have A, B, C. Okay, so C is 8, and A it's 14, and B it's 11. So you have to find out all the 3 angles here. So so I'll let you go ahead and find out the angles. Now, I don't care what method you use. You have your tools. As long as you find out the right angle measure, I'm happy. Okay, so again, you have your tools: law of sines, law of cosines, adding angles up to 180. Okay, so go ahead, take a minute, 2 minutes to do it. Now, there's no particular order of which angle you want to find first, as long as you find it correctly. For me, I'm just going to go ahead and find out angle A first, and angle ABC. Just go ahead and find out A. So for me, I would do the A squared is equal to B squared plus C squared minus 2 BC. BC cosine of A. So I would substitute in the numbers. So 14 square, 11 square, and then 8 square minus 2 times 11 times 8 cosine of A. Okay, so I would just move all the numbers to the other side. So I have 14 square, which is 196, minus 11 square, which is 121. Well, you have 75, minus 64, and then divided by negative 2 times 11 times 8. So you have cosine of A, it's equal to negative 0.0625. Let me just double check So 14 square minus 11 square minus 8 square, which is 11, and then divided by negative of 2 times 11 times 8. Yes, negative 0.0625. That's cosine A. And then A, it's equal to cosine inverse of negative 0.0625. And angle A is going to be an angle that's bigger than 90 degrees. So that is 93.58 degrees for angle A. Okay, so so my drawing does not reflect the actual drawing, so it's not drawn to scale. All right, so that's your angle A, measurement of angle A right there. So you may continue to use law of cosines, or you may use law of sines to find out the other two angles. Okay, so so I'm just going to go ahead and use law of sines so that you can practice to find out the angle B. So I would say sine B over B, it's equal to sine A over A. And I would say that sine B over 11, it's equal to sine of 93.58 degrees over A, that it's 14. Okay. So sine B, it's equal to this fraction multiplied by 11. So let's go ahead and see what it is. So we have sine B, it's equal to 0.784. And then to find out what that is, we do the inverse of 0.784, inverse sine of 0.784. And you have the B, or the measurement of angle B, being 51.63 degrees. Okay, that's B. And how would I find out angle C? I'll just do 180 minus. Okay, so 180 minus 93.58 minus 51.63, and that should give you 34.79 degrees. Right, so now sometimes your rounding could alter the digits slightly, and that's fine. No matter how you round, I don't think that would affect all the way to the ones digit. So if you say, can I give you a 34.8 instead of 34.79, I would say that's totally fine. Okay. Now, at the moment, after these two examples, I would like you to turn to the back page of the worksheet, so the very last page. I want you to look at some word problems, actually. Okay, so I want you to take a look at number 5 and number 7. Okay, I want you to take a look at number 5 and number 7. Okay, so go ahead, take 5 minutes to work on it with your partner, with your neighbor, with someone around you, or by yourself. Anyway, so take 5 minutes to work on these two problems, and we'll go over them together. Well, number 5, let me go ahead and draw the lovely diagram here. So you have a parallelogram. So you have a parallelogram here. I'm going to draw a perfect parallelogram by using the properties of parallelogram, which is the opposite sides must be congruent. So you have 40 centimeters, and the opposite angles are always congruent as well. So this angle, the larger obtuse angle, is 116, and you are asked to find the larger diagonal right here. Okay, so you're asked to find the larger diagonal. Okay. You're asked to find the larger diagonal. So, well, make sure you are labeling everything. So in this case, are we going to use the law of sine or law of cosine to find out this? Cosine would be better. Okay. Now there are some students thinking about this. Okay, let's just say this wild thought just somehow storms into your mind. Are these two angles the same? How can you tell? The answer is no, but how can you tell that these two angles are not the same? The opposite sides are not the same, right? If these two angles are the same, then we are dealing with isosceles triangle, and the two legs will be the same, but we do not have the same legs for both sides, so so therefore they're not the same. So don't make that rash and incorrect conclusion. So we will do our missing side right here. So let's just say x squared is equal to 40 squared plus 22 squared minus 2 times 40 times 22, and then cosine of 116. Again, the main character here will be the angle and the side. They're opposite to each other. So just go ahead, calculator work all the way. Calculator work all the way. 40 squared plus 22 squared minus 2 times 40 times 22, cosine of 116. That would give you, that's a pretty big number, 2,855.53. So then you take the square root of that number. It should give you a 53.44. Does it make sense to have a number that's 53 in this case? For this length right here to be 53, does it make sense? Why does it make sense? Yeah, it's bigger than the other two sides because this is across the biggest angle. It's bigger than it's across the obtuse angle. So this purple side must be the longest out of all three sides. So that's how you can tell if it makes sense. Okay, so that's the word problem here for number 5. And let's take a look at number 7. A triangular parcel of ground has sides of length these 3 feet. Find the measure of the largest angle. So go ahead, draw the triangle. Draw the triangle and label the angle of interest in this case. Okay. Draw the angle of interest in this case. All right. So the angle of interest, it's which one? The top one, the left one, or the right one? The largest angle must be the top one because yeah, it must be across the largest side, right? So what you learned back in geometry is still very useful. Okay, so so that's how we want to find out. So let's go ahead and say, let's say this is angle A. Okay, make it easier. So you are about to deal with some very big numbers. So you have 725 squared plus 650 squared plus 575 square minus 2 times 650 times 575 and cosine of A. Or you can, if you can memorize the other one, you can go straight and use that one. But, huh? Now that's a good suggestion, but multiply, if you divide by 5, it's first, it's not that useful. Second, these numbers are squared. So you want to be careful. And I would say, since you are doing all the work with the calculator, just stay with the calculator. Okay. So 725 square minus 650 square. So I'm subtracting these terms to the other side. Minus 650 square minus 575 square. And then divided by negative. Well, and by the way, when you are dividing by a product, make sure you use parentheses. If not, the calculator thought that with the calculator would think that you are still multiplying. Okay. So I've got cosine of A, it's equal to 0.3043. And by the way, based on your knowledge of sine and cosine, it should be a number well within 1 and -1. Okay, if your number right here somehow exceeds 1 or less than -1, then you know something is wrong. So angle A, it's simply the inverse cosine of 0.3043. So your measurement of angle A, the largest angle would be 72.28 degrees. Okay, so these word problems are not really that challenging, but you still have to know how to draw pictures and identify the largest angle, like in this case. All right, now let's go ahead and do number 8. A surveyor, it's mapping a triangular plot of land. He measures 2 sides and the angle formed by these 2 sides and finds that the lengths are 400 yards and 200 yards. Okay, and the angle in between them, it's 50 degrees. So we're asking, hey, what's the third side? And then also, what's the area? Okay, so you have 3 sides in one angle. So a perfect situation for you to use your law of cosine. Okay, so let's just say this is x. So we'll say x squared, it's equal to 200 square plus 400 square minus 2 times 200 times 400 and cosine of 50. Okay, so I'll let you go ahead and do the computation. And you can also go ahead and finish the area if you still remember the area equation from yesterday. So I have 200 square plus 400 square minus 2 times 200 times 400 and then cosine of 50. Okay, so all these together, double checked, I typed everything correctly. X squared gives me 97,153.98. And if I take the square root of this number, I would get 311.7. Okay, so that's my x in units of yards. Okay, that's my x value. Okay, they're missing the third side. And okay, I would say that makes some sense because it's not the largest angle, so it should not be the largest side. Yes. If they give you what again? The side instead of the angle? Find the angle? Yeah. Okay. And to find out the area, do you still remember the area of triangle from yesterday? 1/2 AB sine C. Okay. And the angle C must be in the included angle. So you have 1/2 A and B sine of 50 degrees. Okay. So 400 times 200 divided by 2 times sine of 50. That would give you a number which is pretty big. 30,642 square yards. Okay, 1/2 AB sine C. Okay, so that's the area. So by now you have the law of sines, you have law of cosines, and should be able to handle these work. Okay, should be able to handle these work.